All right, let's pull back the curtain on something we use every single second of our digital lives. We're going to demystify the network, figure out how in the world our devices actually talk to each other. You ready? Let's jump in. Seriously, have you ever stopped to think about it? You snap a picture, tap send, and boom. Before you can even blink, it's on a screen halfway across the planet. How on earth does that happen? It feels like straight up magic, but what's behind it is actually a pretty brilliant system. And the answer to that magic trick is the network. It's this massive, invisible web that our entire modern world is built on. And today, we're going to make that invisible web totally visible and, actually easy to understand. Okay, so first things first. Before we get into the nitty-gritty of how it all works, we've got to get on the same page about what a network is. What are we even talking about here? At its absolute heart, a network is really just a bunch of connected devices. And their whole purpose for being connected, it's to share two main things: data, like that photo you sent, and resources, which could be anything from the printer in your office to some massive server humming away in the cloud. Now, to make this whole thing super easy to wrap our heads around, let's use an analogy. Just imagine the entire internet as one gigantic, unbelievably fast postal service. This idea is going to help us see how all the different parts fit together perfectly. Okay, so if we're running a postal service, we need addresses, right? We've got to have senders and receivers. So who are the members of our digital postal system? Well, in the world of networking, every single connected device is called a node. And that's a really broad term. It's your phone, your laptop, it's the server that hosts your favorite website, it could even be your smart fridge. Basically, if it can send, receive, or even just pass along information, guess what? It's a node. So, sticking with our postal service idea, the nodes are just the endpoints. They're the houses that are sending and receiving the mail, and they're also kind of like the post offices that help sort all that mail and get it where it needs to go. Simple as that. All right, we've got our houses and our post offices, but how does the mail actually move from one place to another? I mean, you can't just wish it there. It needs roads to travel on, and it definitely needs traffic rules to stop everything from turning into total chaos. And that, right there, is where links and protocols come into play. Think of it this way. On one hand, you've got links. These are the roads of our network. They're the actual physical connections, like a fiber optic cable buried in the ground, or wireless ones, like the Wi-Fi signal in your house. And then, on the other hand, you have protocols. These are the traffic rules. They're the super important set of instructions that every device agrees to follow so they all speak the same language and the data doesn't just get lost or jumbled up. And now we get to what is, for me, the coolest part of this whole thing. We've got the senders, we've got the roads, we've got the rules, but how does something huge, like a full-length, high-definition movie, actually make its way through this system? I mean, think about it. You would never try to cram an entire car into a single envelope and drop it in a mailbox, right? Of course not. You'd have to take it apart, piece by piece, and mail each part in its own box. Well, guess what? Digital information works the exact same way. That movie file is way, way too big to send in one go. So the whole process happens in a few really clever steps. First, your big file gets chopped up into these tiny, manageable pieces called packets. You can think of each one like a little envelope with an address on it. Second, all those little packets are sent out into the network. And here's the wild part. They don't even have to take the same path. They all travel independently, zipping along the links and following the protocols. And then finally, when they all arrive at their destination, they're put back together perfectly in the exact right order. It's an absolutely incredible and resilient system. So, okay, we've got nodes, links, protocols, packets. I know it sounds a little technical, but why should you care? Why does any of this actually matter? Well, because this surprisingly simple system is the engine that makes your entire digital life possible. You've really got to let this sink in. This whole idea of just breaking things down, sending them off, and putting them back together again is the fundamental building block for pretty much everything you do online. I mean, just think about it. When you're sharing that photo with family, you're sharing data. When you open a file from a shared company drive, you're accessing a shared resource. Every single time you stream a movie, play a game online against someone, or jump on a video call, you are using this exact system of tiny little packets flying across the network. So here's the main takeaway, the crucial point. What feels like magic is actually just a really elegant and logical system. It's a group of connected devices, all agreeing to follow a common set of rules, sharing data and resources by chopping them up into tiny pieces. That's it. That is the foundation of our entire incredibly complex digital world. And that leaves us with a pretty fascinating question to chew on. We started out just sharing files and access to printers. Now we're sharing massive amounts of processing power and streaming entire virtual worlds. So, as our devices, our homes, and even our cars get smarter and smarter, what new kinds of resources are they going to start sharing across the network? Something to think about. Thanks for joining me.